Welcome back, woodworkers. Alright, so just made a video about making these grooves here on to this piece. I now need to have a corresponding groove that will line up and come up this side. So I need to start with this, and then I'm not going to trust measuring. I'm actually going to put these together, and then I'm going to gauge exactly where these grooves need to go. That gives me a double check if I'm going to have success at getting this joint correct or not. Now, the situation that is a little bit different from what I just did on the table saw with using a dado blade here, that cut goes the entire length. It goes all the way through this board, which is great, it's easy. A couple problems for this application on this board is that I don't want that groove now to go all the way through. I need to actually stop it on the beginning of the cut and then the end of the cut. This is going to be a bit of a toolbox, so I'm going to make these curved areas here. I don't want that groove to extend all the way up where I'm going to capture or place a panel. It's going to line in this groove here, line in this groove, one on the other end. And I need to capture it in those places. If I had this groove extending all the way up, number one, I would see it, and I don't really love the way it looks. The other thing is that there would be nothing to hold in, so I could pull this out. Maybe that's part of your design, that would make sense. But for this toolbox, I want to be able to capture this panel or this side. So what I'm going to do is I'm going to stop the cut, or I'm going to start the cut here, not touching the end, and then stop it so it doesn't extend out of the shape of this. So there's a couple things that I need to do to set it up, and I can't use a table saw like I did for this application. Pardon me. Okay, so I've transferred the shape on the outside here. I have some ideas about what the handle is going to look like, but I've transferred the dimension of where I want this thing to end. And so this is where the curve is going to start to take shape. So because of that, I need to plan on where the curve starts and then my groove ends. I need to make some gap here, or difference. So I still need some short grain in that environment to really hold this panel into place. So I'm going to make a mark here. That appears to be about 3/4 of an inch, which is great. It's kind of good practice. So I will do that. I need to now transfer that to the other face. So bear with me while I do that. So that's going to be the stop cut. Now where I start is kind of a different story. It's going to need to correspond to the groove that I made on the other piece, and that groove, the height of the blade on making that other groove, created basically half of the thickness of this board. Now I can tell what the thickness was because of where this shoulder is and where the end of this tail is, this dovetail. So I need to make a line here, and that's basically where my stopping point, or I'm sorry, my starting point is going to be. So I'm starting there, stopping there. Alright, so from that, transferring these lines around. And if I overcut this just a bit, no problem with that. It will save me a little bit of handwork on the other side. Okay, so now I have the two marks on the outside face. I've made a mark here, outside, L for left, so I know that I want to read these things as I'm making these cuts, because those cuts only need to be on the inside of this particular project. So if I'm not looking at these things, then I've inadvertently flipped this around, I'm cutting those grooves on the outside, which doesn't serve any function for me. So, alright, now that I've done that, now let's talk about the router a little bit. So I'm going to use the router table. So router table is this thing, it's a table. In essence, there is a motor in it, which is called a router. So that was your router table tour. This is our collet. The collet is the thing that holds our router bit, and the router bit I have grabbed because of the dimension, and this is a 1/4 inch, matches the 1/4 inch that I cut on the table saw. So this is how I've loaded this thing up. The thing about loading the bits into a collet is that I want to, if you can envision the length of the shank of this router bit, right, so the part you can't see now, that goes into the collet. And I want to extend it to the entire length of this collet so that when it's clamped down, it can squeeze all the way around the circumference of this bit, but also the full length, giving me maximum grip or capture of this router bit. If I were to extend this out, and I'm going to hold my fingers here at maybe a 1/4 inch there. If I were to do this and then clamp it down, you can see all the other area that I'm not getting to hold and secure this bit. And what happens with that, as we're cutting, there's a lot of vibration through the torque or the force of the wood being cut through here. This bit can actually vibrate out of the collet, and it usually does that in times you could at least afford it, and it always cuts through all the way on the face of your board, and usually ruins the workpiece. So anyway, for safety and peace of mind, I'm going to load this in here so you can see that the shank extends all the way out of the collet here. I really don't gain anything if I have this extending any further past that point. So I just want to make sure that I've got the maximum length of this collet. So I've done that. Trying to stay in frame, in frame. Yeah. All right. Now I need to tighten this thing up. So there are 2 nuts that hold this thing together. The collet we talked about. Then the locking nut is the piece that's connected to the router. So bear with me. I lock this together. Alright, so I've got this snug, and now with just one hand I'm going to squeeze these together and really start giving it some pressure. I don't want the vibration, as we talked about, to be the reason that this operation fails. So I'm going to lock this thing down. Unlike most things in the woodworking environment, this is one of those applications where you can really kind of lean into tightening that down. All right. Now, this is a huge opening here as I'm running bores through. This is a wide bore, so maybe it's not a big deal, but I really hate seeing this amount of space open. If it were a narrow board, and if maybe I was doing something on the edge, this potentially could tip into that opening, which I don't like. They have different throat plates, different diameters here for this same router. This one is a good size for minimizing the amount of gap, as well as giving me good structure all the way around to rest my board on. So getting rid of the throat plates work. So just like the conversation about setting the height of the bit, or the height of the blade on the table saw, I'm going to do the same thing here, and I want to raise up this bit until I'm no greater than half the thickness of the work. If I extend this too far out, I really leave a thin little section here of material holding this half to that half, and that there's not a lot of strength there. So I could measure this, but to eye that looks great. If ever I'm worried about this, I'd always err on the side of caution and lower this a bit down a bit. The last thing I want to remind everybody is this is how my router table raises and lowers, which is a huge benefit. Some router tables don't have access on the top. You'd have to go into the cabinet and raise and lower the router, and then come back up and check it, and back and forth. Anyway, this is kind of a must just for time savings and lack of frustration. What I'm doing is I'm lowering the bit here, and I always want to raise the bit up to the final height. So once I've done that, I've engaged all the threads to hold this in that position, and that will hold this for the application we're getting at. Sorry for the clanging of the wrenches. Okay. So I didn't discuss the router bit selection, but let me show you with these two examples. So I've used or selected something with a helical spiral in this. This is a 2-cutter helix. This one has 4 different cutters. Slightly different operations, but the same concept. And this is, I think, a steeper helix, if I remember correctly. But the benefit of something that has a helical cutter on it is that all the way around is a cutter. And as this thing is rotating inside of the work, there's always some level of engagement with this bit onto the workpiece. Conversely, if I were to use a straight bit, I would have a situation where I have a cutter over here, and it's only every half revolution that this is actually engaging into the cut, and so on and so forth. So I think this is a gentler cut because of the nature of more of the shearing that happens with this. This one introduces a lot more surface area as it rotates and does the cuts. So I think you get a better cut with this, and also it has less tendency of kind of moving around. Nothing wrong with a straight bit if you have one. If a straight bit is what you've got, then that's what you got, and that's going to be great. You just need to be cautious a little bit about speed. Ultimately, if that bit is sharp, then you're going to be in great shape regardless of what techniques you might modify here. Okay, so I have this thing set up. What I now need to do is align my cut. So I've traced where this needs to be based on what I've done on the table saw. Forgive me 1 second. Okay, so with my router fence, I have the option of sliding these fences in and out, and that would make sense if I had a bit that I need to extend here, and then the bit would need to go between these. Let's say I was cutting a sliding dovetail, or maybe there's a slot cutting operation I need to use. So I could put that bit in between these fences and then lock the fences in and go about my cut, and I'm just cutting on the edge. For this application, I really don't need to have a bit between these fence areas. So what I'm going to do is lock these off and create more of a smooth environment for this board to run across, which is really what I want to do. So with router fences, just like drilling on a drill press, it doesn't matter what it is that I am, the alignment of this fence in relationship to the bed or whatever. Because this is a round cutter here, I can skew these fences, or this end of the fence, pretty easily. I'll probably do that. I'll probably lock down one side of the fence and make my adjustments on the other to get this dimension exactly where I need. So this is a strong 1/2 inch. Oops. Alright. So I'm at the wrong side of this cut. That looks better. The other thing that I can do, this alignment here is going to be critical. Let's carry these lines down so that I can line it up exactly on where that cutter is going to engage. Bear with me while I do this. That looks a whole lot better. Alright, I'm happy with that. Do the same on the other side to see how close I am to being symmetrical. That looks pretty close. Okay, so what I've done is, you remember our first step was transferring these lines up to where I need to start and stop this cut. What I now need to do, you'll notice that there are some lines on the fence of this table saw. I'm going to replicate that here. I want to rotate this bit so that it engages with one of the cutters. I'm going to make a little mark here, flip this around, make a mark here. I'm doing this with pencil because I will be erasing this when I'm done. So I don't want this to interfere with my next operation, whatever that may be. Great. Okay, so now I know where the outside of this bit is and where my cuts need to go. Now I just need to line them up. So the process is going to be, I'm turning on the machine, we're up to full speed. I engage this edge against the fence, and then I'm going to be dropping this thing down onto that spinning bit. But the bit, a router bit, any router bit, is not a drill bit. It's not really intended to do a plunge cut like this. It really only cuts on the sides efficiently. So as I'm dropping this down, I'm always keeping this edge tight against the fence, and I'll be rocking it back and forth slowly until I get this all the way flat onto the bed of the machine. So I need to line up where I need to make this cut, and so that is where this line and then the outside edge of that bit is going to be. So what I want to do is set up a stop. I'll double check this here in a sec. Without setting up stops, then I'm in a situation where I'm going to have to freehand this for the cuts I need to make, and in this application I'll be making 4 cuts. So I prefer not to freehand this. I like repetition or repeatability with what it is I'm cutting. That looks pretty great. That looks pretty great. Okay. So for the most part, that is going to be the setup. I'm doing on time. Okay. So there's one other thing that I have to do before I can make this cut on the router table, and it has everything to do with the short grain that's going to be presented here on the end of this tail. So this bit's going to be running like crazy. Depending on the pace by which I advance this, there's going to be an incredible amount of force at the end of this cut. And unless I relieve that force or that pressure, this chunk can start to pop out. And it's not going to pop out cleanly. It's going to be this nasty thing where this whole thing leaves the part that I care about. And the whole thing about doing a stop cut is I don't want to have any evidence on the end of this board or on the top where I'm going to see this groove. So I'm going to relieve a little bit of that pressure, and I'm going to do that with a handsaw, and I'm going to make a little cut in here, hopefully not touching this tail, but cutting through the inside of this tail. Once this is glued together, I'm never going to see that, but if I don't do it, the risk is just too great. I'm going to do that on all 4 of these tails. So let me do that, and I'll be back and we'll cut this together.